Okay, next up we have Breana Hashman from Geoscience.
I want you to think of Star Wars, Star Trek, Doctor Who. As a society, we are fascinated by the search for extraterrestrial life. Today, I want to convince you that the search for alien life doesn't begin in a galaxy far, far away. It begins here, on this planet, with rocks from early in Earth's history. Right now, the Mars rover Curiosity is sitting in a crater, studying rocks, trying to find signs of past life. And the big question is, what are these signs going to look like? This is where my PhD comes in. When we're looking for extraterrestrial life, we need to base this search on the knowledge we have of life on our own planet. And if we look back in time, we know that for the majority of Earth's history, the only life that was around was simple microbial life, like bacteria. But these microbes don't tend to leave fossils. So if we're going to find traces of past life, we need to find the chemical signatures that they leave behind in the rocks. And so as an astrobiologist that's also a geologist, I look at rocks from early in Earth's history to find the chemical signatures of life. So that will inform us about finding life on other planets like Mars. So these biosignatures that I'm looking for, they are created by the eating habits of microbes. Now, microbes eat different elements like carbon or sulfur to get the energy they need to survive. But elements can have different masses called isotopes. And microbes can be picky eaters, and they may preferentially choose to consume a lighter or heavier isotope of an element. And this is a process called fractionation. Now, humans have fractionation as well. They fractionate their food. Imagine you have a bag of Chex Mix, and you open it and you get that wonderful smell of MSG, and you start to eat the rice Chex, you start to eat the mini pretzels, but then you come across a bag of rye chip, and you're like, oh, bag of rye chip, and you drop it back in the bag. And so you can imagine that over time, the proportion of the contents of the bag would be larger and larger amounts of the bag of rye chips. This is what I look for in the rock record. I look for the microbial equivalent of the bag of rye chips. I'm looking for the isotopic signature of life, or the Chex Mix signature of life. So for my research, I'm applying this technique, this isotopic technique, I'm using this to find the chemical signatures of early life and 3-billion-year-old rocks that I collect from South Africa. And this work is funded by NASA, which you may expect, but it's also funded by the American Philosophical Society. And that may surprise you at first, but if you think about it, even though this research is science, it gets at these deep philosophical questions, like how did life begin on this planet, and are we alone? And this is why I love my research, because my research is it's not based in a galaxy far, far away. It's based on this planet, looking at how life started here so that we may be able to find life elsewhere. Thank you.